have you done those tasks actually for the DD algorithm?
Yes, sir.
Yes. What about others?
Sir.
Okay.
Yes, sir.
All right. So I hope that you have found those are very easy, and can you see in the screen, right?
Yes, sir.
Yes, sir.
Okay. And okay. And those a few problems you have seen that in different actually angle, that means the slope, according to the slope, that we can have the variation. So one of the concern that we have in the DD algorithm, that the line you have got, say like we have got like this line. One of the case, the line we have got is something like this, right?
Yes, sir.
This line, maybe the slope is less than 1. So the problem you have seen here, the pixel, they are in such a way that a smooth straight line, it's not looks like a smooth straight line you can get. It looks like that it can have like a zigzag, means edges. There are some edges of the line. So it can have a scenario like that for the line, where actually this DDA is not actually sufficient, or DDA is not very efficient in that case to get a very smooth line. So maybe we need to think about a different algorithm which can give us maybe a more better line. That means whenever we have actually that kind of situation, then we can actually, you can select, or algorithm can actually select the best one for the line. So that we are going to discuss today in Bressenham's line drawing algorithm. But before that, you make sure, because I already have said in your midterm you will have a problem from the DDA, one of the problem. So you make sure that you can do it. Okay. And you can see that there are chances of your this midterm might have many number of mathematical problems or this kind of related problems. So we can have multiple number of set. So there the values will be changed, the type of the line will be changed. So it is better you can do it, because maybe the sharing of the answer will be difficult this time. Right. So what was the problem you had? Can you tell me that the values I have given you yesterday? Protasha, can you tell me that?
Yes, sir. The value of P125 and oh, sorry, sir. There is 2, 3, and 4. You have given 3 math. Which value you need?
No, can you just tell me then one of the problem? Can you please just show me that what actually you have solved? Because I don't want to solve it, but at least if you show, then maybe the other student, those have not done it, can have some idea.
If I need to show, then I need to join with phone.
Oh, you need to join it. Shaunika, you can, or maybe anyone else that you have done. What are the 3 lines? Can you tell me? Then maybe I'll try to show.
You want to know the value of x1, x2?
Yes, that points.
Yes, sir. The value for x1 is 5, y1 is 4, and x2 is 12, and y2 is 7.
All right, that was one of the problem, right?
Yes.
And another one?
So another one is x1 is 5, y1 is 4, and x2 is 12 and y2 is 7. Oh, I
No, you
said the
just
same value.
same value,
Sorry, sir.
yes.
Sir, x1 is 5,
Hmm.
y1 is 7, and x2 is 10, y2 is 15.
Okay. All right. That is this one. Maybe you can get. I think 5, 7,
Yes,
10,
sir.
15, right?
Yes, sir.
And we can find it here for this case. The slope is greater than one.
Greater
That means
than
a
1.
line kind of a actually going through like this one, that number 4.
Yes,
Okay.
sir.
All right. As you can see here, how what is the process? Quickly, just I'll discuss. So x1 x1 y1 x2 y2. That is actually the value we get. Then we need to find out the differences, that del x and del y, as we know that x2 minus x1 and y2 minus y1. That is actually the way we gauge it. Then the next step, we find out which one is bigger. That should be my step. So in this case, my step is 8 because del y is actually bigger. And just for information, we try to see that what is actually the value for the slope. We have find like del y minus del x. As we know, that is the slope is 1.6, more than 1. That means more than 45 degree. Now the increment value that we have find out, which is x increment, is actually that del x divided by steps, and a y increment is del y divided by actually steps. So we get 0.6 for x increment, and 1 is actually y increment. That means is every cases y value has been changed by 1. Okay, that's actually incremented by 1, whereas the x value has been actually incremented by 0.6. So that we have actually put that value, started with actually 5, 7 the first point, that should be go up to actually 1, 2, 3, 4, 5, 6, 7, 8, because my step is actually 8. So number of iteration should be 8. So 5, 7 become 5.6, and 8, 5.6 in round value is actually 6. Then 6.2, then 9, 6.2 is 6, 6.8 is 7, like this. So it goes up to 9.8, which is actually 10 and 15. So if we put those points or pixel in the graph, as you can see the graph, okay, so you can see here that these are the actually pixel that we have plotted, and maybe a possible line can go through like this. Here you can find out that there is a scenario that two pixels, one after another, that actually you are actually going through, the line is going through in that. So maybe if you could have taken one of the pixel, maybe that is actually better. Maybe you don't need two of them, as actually the line could be seen as a smooth in the screen. So that's in that case actually that our Bresenham line drawing algorithm will work out. Okay, so we are going to start that one. Before going in that, let us have the attendance, then we are coming back.
Sir,
Yes.
sir, whenever we draw the chart, at that time, for the round value of x, we need to draw the chart in the left side of x value, or we can also draw it on the right side of the x value. You have shown that the
I
x value, round figure of x value.
now that happens actually. I did not have any space, so that's why actually I put that on the left side. Okay, yeah, just give me a second. Just you can put it in any side. Uh, right side is better. If you have a space for right side, is better always. Yeah. So I do request all of you to come in the video for a while, please. And you know about the midterm, right? That what is the possible time that you're gonna have the exam?
Yes, sir. 10 to 14.
10 to 14 years, all that time maybe. Okay. Do you have Alif Laila Jannat? Ashikur Rahman Ashik? Muhammad Ashikur Rahman Ashik? Muhammad Alamin?
Yes, sir.
Okay. Nishat Ara? Nishat Ara? Muhammad Shahidul Islam Antur? Muhammad Shahidul Islam Antur? Sumaya Akhtar?
Present, sir.
Okay, Sumaya. Arifa Akhtar Ritu?
Present, sir.
Okay, Ritu. Umme Jinatun Nisa?
Yes, sir.
Okay, Jinat. Parvez Alam?
Present, sir.
Okay, Parvez. Redwan Ahmed Ratul?
Yes, sir.
Okay, Ratul. Salvi Sabah?
Yes, sir.
Sabah. Jakaria Hassan Pappu?
Yes, sir.
Okay, Pappu. Maria Mehjabin?
Present, sir.
Okay, Maria. Israt Jarin?
Present, please, sir.
Okay, Israt. Abdul Khalek?
Yes, sir.
Rabina Afrin Ami? Rabina Afrin Ami?
Yes, sir.
Does Nova Ami is here? Okay. Does Nova Yasin Esha?
Yes, sir.
Esha Sharia Toyon?
Present, sir.
Okay, Toyon. Hussein Ahmed Antur?
Present, sir.
Okay, Antur. Protasha?
Yes, sir.
Sharnika?
Yes, sir.
Khadija Ria? Khadija Rahman Ria? Rahat Islam Rupu?
Present, please, sir.
Okay, Rupu. Mahmoud Akhtar?
Yes, sir.
Okay, Mahmouda. Didar Al Mahmoud?
Present, sir.
Okay, Didar. Tamanna Tabassum?
Yes, sir.
Okay, Tamanna. Saif Mahmud Sifat? Saif Mahmud Sifat? Fairuz Tanjim Achal?
Yes, sir.
Okay, Achal. Sadiatun Nisa Shetuli?
Yes, sir.
Okay, Shetuli. Mustafa Iram Udoy?
Present, sir.
Okay, Udoy. Sadia Hussain Mori? Sadia Hussain Mori? Sadia Akhtar?
Yes, sir.
Okay, Sadia. Mantakimur Rahman?
Yes, sir.
Atik Faisal Imun?
Yes, sir.
Imun. Rahul Devnath? Rahul Devnath? Nishat Taslim Jyoti?
Yes, sir.
Jyoti. Sadat Mahmud Khan?
Yes, sir.
Okay, Sadat. Firdaus Hassan Rifat?
Yes, sir.
Okay, Firdaus. Minhaj Munib? Minhaj Munib? Nahida Islam?
Yes, sir.
Okay, Nahida. Hasibul Hassan Shanto?
Yes, sir.
Sharmin Sultana?
Yes, sir.
Okay, Sharmin. Ryan Hussain?
Yes, sir.
Okay, Ryan. Muhammad Alamin?
Yes, sir.
Alamin. Tariqul Islam?
Yes, sir.
Tariq and Muhammad Ashiqul Jaman.
Yes, sir.
Okay. All right. So, anyone missed? No, not really. Yes,
Sir, Khadija Rahman is present.
Khadija Rahman Ria. All right.
I have a question.
Yes, please.
Whenever we will find a zigzag line, not a straight line, in our exam, should we draw the line, zigzag line over the pixel?
Especially for GDA, when you have actually all those points, you have to actually draw that line, and you have to accept those points. Actually, there is no other way, because that is give you according to the algorithm. For the calculation that you are doing, that we have done actually over this using this algorithm, that is only for few points. Actually, the algorithm works on when in your program in the computer, then actually you may take a few hundred or thousand of those pixels. So you cannot sort out of them that which one you will check and which you will not. But what actually we are going to do for Bresenham's line drawing algorithm, another algorithm that will automatically take actually the best one. Okay, so that's why you don't need to actually worry about it. But for DDA, if your exam you have, then you have to draw according to the points that you have got. Okay, Pappu?
Yes, sir. Thank you.
So did you start the new algorithm?
Hmm? Yes, sorry. Someone said something, I missed it. All right. Now the scenario that actually we are going to discuss, that is related with, is it showing to everyone? Yes, we have the spotlight. Okay. The scenario we are discussing in here, as you can see, let's say like I have the pixels. Better let me draw in a new page. This is actually the pre-discussion about this algorithm, and the derivation of this algorithm usually I do in the during in the physical classes in the university, but you need actually that kind of environment. But in here it would be difficult through online, but it's still the pre-discussion that we are going to do, so that you can at least understand the algorithm. That's there are some calculations, some formula automatically come, but actually it does not come automatically. It has some that is called the generation technique of that algorithm, or derivation of that algorithm. So I'll try to do it in short, that what actually we are going to do. Say like a scenario for the screen, where you have actually that pixels in this fashion. Now consider that you are actually having a line. It is going through like that. Okay, and in here we consider that this is actually all our pixels midpoint. Midpoint in that concern that any pixel, if I want to identify, these are some of, if I consider this pixel and this pixel, whatever, so we better take the center point. The line has been going like this way, say. Now it has been drawn in such a way that it may confuse that whether it is.
Sir, is it
We will.
linear equation?
Sorry,
Is it
linear.
yes, sir. It's looking like that.
This is my straight line going through the pixels, okay, and the problem is why actually we are telling it as a problem, that this line is going through this pixel and this pixel, right? According to the DDA, both will be actually considered, and the line is actually going like this way. As you know that uh, this is not possible, a line always go through in middle of the all the pixel. You have seen it that in one of your example as well, that it does not go like this way, right? It consider actually when you think about it, the line is actually going like touching the pixel. Some may be a part of that, some may be actually a little bit part of it, okay. So it would be better actually if I could have drawn in more in such a way like this one I'm talking about. Say like I have a pixel like it, and there is another one. A line is actually going like this way, say, right? So this line is touching this pixel, also this pixel, right? Now, which pixel should be light up? If computer want to consider, then which one they should actually consider? Definitely this one, right? Because it is actually going the most of the part. If you don't light up this one, then the light is still, that will be look better, because the next pixel that is actually going this one, so this one will be light up, this one will be light up, right? But we don't need it to light up this one. Do you understand?
Yes, sir, got it.
But the
Now-
minor details will be missed.
Sorry,
But the minor details will be missed.
what do you mean by detail?
So if you consider a line, we have seen earlier that every pixel, if we light up every pixel, then a statal will be shown. But if we I don't know, if we don't take the upper part of the pixel, should it be okay? I think some of the light will be missed.
Then the line will looks better, because this one is more advanced algorithm than the DDA. DDA, you have seen already, the line that is going to draw is it is, you will not feel it, but actually the line is not properly a straight line, because there will be zigzag, okay. Some part of the edges that you have which is unnecessary, like this one, if we light up all three of them, then definitely the line will not be better, okay. I am just considering that definitely a straight line, when it goes through, if you go to the pixel level, we cannot see in the pixel level in our naked eye, because as you have seen, there's millions of pixels there. But still, if we can go and can check, then if we can actually want to have a very fine look like a straight line, then we have to consider some of the pixel, not all the pixel. Now, DDA algorithm does not actually provide it. It takes all the pixels in between whatever they get. But this algorithm, the Bresenham's algorithm, that actually provide the best pixel which it should be taken. Like this, out of these two, that it should take actually this one. It will not take this one. But how computer in a logic that actually know, because this is through your naked eye, you will definitely know this should be taken, right? This is not. Why? Because line is going most of the part of this pixel, a very few tiny part of that pixel. Do you get my point, Uday?
Yes, sir, I got it, sir.
Yet now that's actually the algorithm will identify, and you see here that considering that scenario, you need to have actually kind of a decision to take. Out of the two pixel, whenever you have a scenario like it, which one I will take? It's matter of a decision. So algorithm will actually support you to take that decision. Automatically it will take the decision. Now definitely computer doesn't know any magic, right? And also it does not have that intelligence that with the visual or maybe whatever the calculation value you are getting, on basis of that it can make it actually different. So it all about mathematics that you need to identify. Okay, so that what they are going to do, they are going to do that joining that line. Okay, if you join, then you get a point in here, right? The distance of this line, that point indicating the distance of this line from this 2 pixel. Now if you want to find out the distance of them, of this line between these 2 pixel, you have to make a distance from the center point of those pixel, right? You will not take any random any position for that. So the distance of this pixel to this pixel is actually from here to here. Okay, so that's why we just join that line, and we have found like this point has been actually touched in here. So actually what we can do, we can call that this is actually my, the point is, I give a name, is actually my y point. Okay, y, and actually the coordinate for this one is actually xi plus 1. If I consider this is my x of I, then what should be the coordinate for this one? X of I plus 1, right? X of I plus 2, x of I plus 3, like this, right? Then if we consider this pixel, that position is y of I, then this should be y of I plus 1, this should be y of I plus 2. Yes, do you agree?
Yes, sir.
Oh, okay,
Yes,
that's
sir.
good. Then the distance, if we just join that line of this one, and if we just join that line of this one, you can see here that this is actually my 2 distance, right? From that line for this pixel is actually, this is the distance. Yes,
Yes, sir.
yes, we give it a name d1, the distance 1. And from that point, okay, this is we are calling y, the line has gone little bit up actually. From that point to this pixel, the distance is actually this one, we call it d2.
Sir, it's getting very difficult to understand what is the exact line now.
What is the exact?
What is the
Sir,
exact
if you
line
have a
was
different
it was
color of pen,
before?
that would be better.
Yes, sir.
Okay, at least you can get it now. Okay, I don't have any different color at this moment, but at least you can understand that from that point, the line and the distance from those actually pixel that we have, this is actually my pixel. Okay, I just make it little bit darker. This is actually the pixel. Okay, this should be in here. I just made a mistake, it should be in here. That is the distance, right? This point to this point, that means this point to this point. Is it still not very much identifiable? I am actually
Yes, sir.
showing in here as well. Here, this is the D1, okay, and this is actually the D2. Yes.
Yes, sir. We can carry on, sir.
Okay. Yes. Just you can already we have said that which one maybe I can take, right? You have seen that for this case, um, as the line is actually going like this, then which one is better I can take? I can take maybe the lower one, right? It is more
Yes,
like this
sir.
one. If we consider this point, maybe if we go like that, right? And if we just join it, so this is the point maybe we have joined, and we can see here this is my lines. So this is the D2 and this is actually the D1. Okay, you see that already we are getting some kind of hints. The distance, that means D1, if it is less, then take the lower one. If D2 is greater, then take the lower one. Okay, if D2 is smaller and D1 is actually greater, then maybe take the upper one, right?
Sir.
You see that this is actually the logic, right? Now that actually the computer, because you have to give computer some comparative actually analysis, then only it can take a decision. So this is actually our decision. Now these things for a single one that you have done, in the next one maybe you have another pair where maybe your the D1 and D2 is changing for the another pair. Like this way it will go and compare with each and every pair of the pixel on the way, and it will take a decision and take the best one, right? So you see that this is also we need to put down in a loop, and in such a way that actually you can take decision and it will be changed in one of the pair of the pixel. Maybe D1 is smaller, and one of the another pixel you get the same line, maybe D2 is smaller, then maybe you are taking the upper one, right? So the decision, that parameter of the decision also we need to have a change in that. Now this line we are actually discussing, I'll just quickly show some part, some up to that derivation, not all of them, because whenever we'll go for all this formula to show you, then actually you will not understand otherwise. So this is actually we use the formula for y equal to mx plus c, right? That is actually the equation for y, right?
Yes,
Yes,
sir.
sir.
That's actually true for that line
Coefficient.
for anywhere, because m and c are constant, the slope and the intercepting point, and y and x will be changed maybe over the point. Now I am telling this point is my y. The value for the coordinate is actually y. What is the x coordinate value of this point? The point actually I'm talking about, what is the x coordinate of my that point?
Xi plus 1.
xi plus 1.
Xy plus 1, exactly. So that actually I have that xi plus 1 and the y. This is actually my that point, right? I'm not drawing that one so that it will look more complex, but this is actually my coordinate of this point that actually we are talking about, because this point, through this point I am actually making a comparison of the distance of those two pixels, right? Now for this algorithm, it will there are some preconditions that we need to assume, that these preconditions are actually what, that we have actually input that we call, that is actually assumption or preconditions. Because whenever this condition will be changed, then the entire formula will be changed. So the in input the line endpoints, okay, definitely we need those two endpoints, which is x1, y1, and x2 and y2. Okay, those two endpoints that we are actually going to. Now the condition, one of the condition is x1 must be less than x2. Okay, same for that we have done. That means it is indicating that my two endpoints, this one is actually very close to the origin, and this point may be a little bit far away of the origin. Okay, that's indicating this one. And the line slope, okay, that line slope or m should be less than or equal to 45 degree, right? That means actually what? That means that m should be greater than of 0 but less than or equal to 1, not more than 1. So the line should be actually more like aligned like this way, not like this one. Okay, if you go for like this one, then your formula will be changed. So we are actually considering the scenario at this moment, those type of line which are having actually either maybe 45 degree or maybe less than 45 degree. Okay, do you get my point
Yes, sir.
about this condition? Okay, so what is actually the reason for it? You see that if we have a space where actually I have a line like that, if you consider the distance or difference between x coordinates here, okay, this is actually the del x. If you consider the distance of y coordinate, del y, you have you seen that the changes of the pixel here or point here will be done every cases, the x coordinate will be incremented by 1, because that is the major part of the distance. Where the y coordinate, some cases it will not change, some little bit portion will be changed maybe. So that's why we are taking the scenario like it. But if we have a line like this one, say, which is actually more than 1 for that slope, what
Situation
actually
will be reversed.
the situation will be reversed, exactly. So that what actually the x coordinates, the distances, you see that this is only that part, but about the y coordinate distance is actually high, right? The del y is actually too high. So every cases of the changes, the values for the y coordinate will be changed by 1, but the x will be some fractional changes. In some cases maybe I will consider same x coordinate value. Okay, so whenever we come in the pixel basis, you see here that when I have that kind of line which is actually supporting this less than 1 or equal to 1, then every cases I am changing my x coordinate, but my algorithm in some cases is considering the same y coordinate with the previous one. Okay, maybe in some cases a new coordinate means new means actually and 1 incremented by 1 coordinate, but some cases it is maybe the previous one. Like the example I have drawn, it is also going actually the same one. What actually the first one pixel that I have selected, this one, right?
Yes,
And what was actually my coordinate value for it? Xi, yi, right? So I have considered actually the xi, yi, that was my first one. Now algorithm started to work for that actually complex part. The next pair of scenario, yes, there is actually 2 of the pixel. Is there a scenario that which one I should take? So according to our perception that we can actually see, and from that, according to the distance, that we can assume that maybe we are going to take the lower one, because most of the part of the line is going through that light. And if it is lower one, then what actually the algorithm is actually doing, that is actually, you can see the x coordinate is xi plus 1,
Plus
right?
yi. Yes, sir.
And the y coordinate is actually the yi. That is actually considering, right? Now what happened for the x coordinate? Incremented by 1. But what happened to the y coordinate? Same.
So incremented by 0.
Right? That is the same
sir.
one actually they have considered, because that is the same that level that it is. So for that's why whatever we are actually working at this moment, that is supporting actually less than 45 degrees. So a line more like this one. Do you understand now why we have some precondition?
Yes, sir.
Yes, sir.
Right? Because if we have a different type of line which is more than one, then our all the formula that actually we are going to do, that also need to be changed. Okay, all right, that is actually our precondition. If we consider this point, and for that point, which is actually we are considering y, if we have the equation for it, what actually it becomes? Y equal to mx plus c or b, right? Now what is x here? Xi plus 1. Right? This is, we are talking about this point, the equation of this point that we are actually doing. Because if this is the equation of the line, and this is true for any point, so whenever y equal to mx plus c or mx plus b, whatever, so for that point, whatever we have in the line, for every point that equation is true. Only the value of x and y is actually changing, right?
Yes, sir.
For the same case, the line equation that I have taken, y equal to mx plus c, and the x coordinate value is actually xi plus 1. That's why the equation is look like that. Do you get it?
Yes,
Yes,
sir.
sir.
The m is here actually del y by del x, right? Which is slope, and c is called the intercept, as you know, means which is actually intercepting to the point for the y coordinate. And del x and del y is actually x2 minus x1 and y2 minus y1. We already actually know. Now what is d1 now? The d1, if we consider what is d1, this is actually what?
Point.
Yi, right? We are considering this point is actually indicating the yi, and this one is actually y, right? This is yi, this is y, and this is yi plus 1, right?
Yes,
These 3 points.
Yes, sir.
So that d1 is actually what? Definitely the y is bigger than yi, right?
Yes, sir.
So that
Yes, sir.
d1 can be said is actually y minus yi.
Yes, sir.
Yes, we can consider it. What is y minus yi? Y is actually what? M xi plus 1 plus c minus yi, right?
Yes, sir.
Yes, sir.
I just actually replaced that this equation, right, in here. Nothing else. Now what about d2 then?
So
This
yi
point
plus 1
minus this
minus
point,
y.
right?
Minus y. Yes, sir.
So that we can say that yi plus 1, okay, minus y. That is actually my d2. Now what is that yi plus 1 minus y? if we just do it for yi plus 1 and minus m xi plus 1 and minus c, right?
Yes, sir.
Yes, sir.
Yes. Now if we just subtract those two values, that d1 minus d2, okay, consider that d1 as it is coming first, maybe we consider that one first. So if we just calculate d1 minus d2, right, what do you get? We get d1 is m into xi plus 1 plus c minus yi, and d2 is minus yi plus 1 minus will be now plus m xi plus 1 and plus c, right?
Yes, sir.
d1 minus d2. If we do the calculation, simplification of that equation, then we get what? 2mx plus I, right? 2mxi plus 1, right?
Plus
Then
2c.
what about the y? You can see here that y is also actually get minus, and this should be plus, isn't this should be minus as well, right? So minus 2yi, also we get minus 2yi, right? Also we get 2c plus 2c, one c and another c, and this one, for that one, it should be actually minus
Minus
1, right? This is the equation that we get, right? That of d1 minus d2. This is important, as you can see already. We have discussed that this d1 and d2 and their differences, if we can find out now d1 and d2, you see that we already have said that d1 is smaller, then take the lower one, or d2 is smaller, then take the upper one. Now how computer will identify which one is actually smaller, which one is greater, right? We are seeing that from our visual perspective, right? So that's why we need to make a relationship between them, and that relationship will give you some kind of outcome, which is actually can be done through some operation. Okay, so that's why we are doing a operation, and then whatever we are getting, that value are going to give you some kind of idea. Okay, so I hope that the time is up. I have another class, actually consecutive class with other one, so we have to stop in here now. At least some part I will discuss, because I just show you that the equation, it is I take at least 1.5 class, nearly 2 class actually, only for this generation or derivation of this Bessenham algorithm. As you can see here that the equation you get, that equation we need to multiply with del x, because there is a m is actually a nominator, that denominator it has, because it has a fraction. M is actually the value for del y divided by del x for that. So definitely there can have some fraction. We need to avoid for any equation for the fraction, because as you know, we are going to have the integer value for the pixel. Okay, and then actually there are many other calculations that we need to do continuously. We need to do the entire page, and then finally that you get actually the formulas like that. So we will go straight to the formulas for how they can be generated. You can see here that these are actually the formula for that p. There is a new term comes which is called the decision parameter, and then if we understand at least some part of that, then we can apply this algorithm for the problem solving. Okay, so I hope that please do not miss the classes, because is for problem solving you need to understand the algorithm. The derivation of the algorithm that we ask during the exam, actually when there is a physical classes, we have another derivation with for the circle drawing, that is also like the same. But this online exam I don't actually ask for the derivation, because straight away student can do copy. So that's why better I go for problem solving, so that the individual student can do different problem solving. Okay. All right, thank you very much. I'll see you not in tomorrow, maybe day after tomorrow, maybe.
Hello, sir.
Right. Yes, Minhaj.
Sir, I was disconnected during the attendance time.
You disconnected? Okay, send me an email, please. Okay, I'll check.
Okay, sir.
Yes, sir.
Yes, Rahul. Why you are late?
Yes, electricity, sir. Sir.
So there is a storm in our area.
Still, it is in the Uttara as well.
Yes, sir. It's raining.
It's raining heavily, so I had to close the window as well. That it was so strong rain. That is fine. But Rahul, I will check, because for you already I got the request. Okay, so it is really happening for every day or not? That's actually the case. You send me the email, then I will update. It's already have been. You have seen that it is already submitted, so I cannot help at this moment. Yeah. All right. Take care. I'll see you in the next day then.
Okay,
Okay, sir.
Assalamu alaikum.